Hey guys, how's everything going? This is JSer, who is not good at algorithms. In this video, I'm going to take a look at A96 monotonic array. An array is monotonic if it is either monotone increasing or monotone decreasing. If an array is a monotone increasing, if for all elements, the latter one will be bigger than the previous one or equal to that. So almost ascending, right? Or almost descending. We need to return true if only if it is monotonic. Well, it's as the definition, we need to check each element whether it is before it is they are check the relationship between the adjacent two nodes and determine if they are all of the same direction, right? So, well, which is pretty straightforward. I think let the like say direction. Okay, 0 is flat. We use 3 numbers. 1 means ascending, 2 means descending. So we will loop through all the elements and check the relationship between the previous one, and to check if the direction matches, right? Matches the direction. And we will set the direction when we first met something that is ascending or descending. And that will lead us with linear time. Let we need to compare the previous one, so I'll use index for loop. Okay, I may be using -1. But 1 ascending, -1 is descending. No, okay, I just use 1 too. If it's the same, 0 and AI smaller than A -1, then it should be descending. Yeah, like this. So if direction is 0, it's okay. So what we do is set the current direction to it. If not, we need to check if they are on the same direction, right? If it's not equal to the same, if they're not the same direction, return false. If they are the same direction, we will go to the next one. Finally, return true, right? This should work. Ah! Oh no, we got the wrong answer. Really? If direction is 0, we set it to current direction. If this is more than this 2, if not 1. Okay, for the other case, if it is the same direction, we do nothing. But if it's not, return false. Eh? What? Okay, for the input here. So okay, the original direction is 0. And now we get 2, actually 1, so ascending. So we set it to ascending. And then we got 2, so it's flat. Oh my god. If current direction is not equal to 0. Shit. So stupid. Well, I think this should be the the solution. Time must be linear time. space constant, right? Could we improve it? I think there is a case that if we short circuit this fast enough, it will be faster. Say only if the input, if only the last element is in another direction. If that's the case, actually we could to fail a little faster. We could actually, the input will be more than 1, right? We could actually define a direction at the beginning, right? So if the first one and the last one is equal, then all of them should be equal. Yeah, so if this is case, we get a current direction, and if it is 0, this should still be 0. If it is upward, this could be 0. So if this is 0, but this is not 0, if this is not 0, return false. If it is not, else if this should be right. Ah, false. Oh my god. Ah. I'm not at the right mode. They're saying is 0. If it's more than it, then it should be 2. Big 1. Current direction. If the direction is 0, this should be 0. If not, return false. If it's not 0, and then we check if current direction is the same. Not. Again. Again. I'm stupid. Yeah. So it doesn't improve that much because the time complexity doesn't change. Any better solution? 2 pass? So this 2 pass is not good. 1 pass. Yeah, I think we're doing a 1 pass. So we need to remember if it's monotone increasing. If it's monotone increasing, there are some adjustment to width. We keep the, yeah, when we go this, if someone is bigger, then it could not be increasing. This is clever, I think. This one is clever. We could just filter if increasing or decreasing. This is cool. If they are the same. So if this actually has a problem of all the same numbers, right? Increasing or decreasing, true. Yeah. They still cover the all same numbers case. Let's try to write it. Wow, this is this is very cool. So default we say lead or flat, right? So let is us in okay, right by ourselves is ascending a true. Let is descending false true. For I equals 1, if ai is bigger than a minus 1, if it's bigger than it, then it couldn't be descending. Oh yeah, ai is smaller than a minus, then it couldn't be ascending. So finally, either of them is okay, right? Wow, this should be the fastest one, I think, without so many if clause. Well, doesn't change that much because technically the time complexity doesn't change, but it's much cleaner and simpler. Cool. So that's all for this one. Hope it helps. See you next time.